We're gonna deploy a contract. To do so, we'll first to initialize a smart contract. You can name it whatever you like. And once you've created the file, the next thing you need to do is to just write the smart contract in that file. Here, we're gonna deal with a pretty simple smart contract called incrementer, which has only one state variable called numeric val. We initialize that value in the constructor. So when we deploy this contract, the value we give to the constructor will be set for the value of the state variable. It basically will have two simple functions, increase value and reset value. As you can see, reset value resets it to 0, and increase value increase the value by the amount you give to the function. So this is our simple contract. After this, we're going to compile the contract. To compile it and make sure that everything's working properly, we first need to build a script that leverages the Solidity compiler to produce the ABI and bytecode for our contract. We can first make a file, compile.py or .js, and use this code to do the compilation. So you can first import the compiler library, importing solcx. You can then install it by solcx.install _solc function. If you've already installed the Solidity compiler, you can forget about this one. And to actually compile the contract, you can use solcx.compile files and pass it the name of the contract you had. It definitely need to be in the same directory as where you're executing this code. If it's different, you need to give the full address here. This will give you a variable called compile output, and from this compile output we could extract the ABI and the binary file, which, as was mentioned before, the ABI is basically a JSON representation of the contract, and the binary file is a bytecode that will be stored on the chain and everyone will have access to it, and it represents the whole smart contract, and it could easily get decompiled so everyone could see the smart contract. So from now on, whenever someone asks you how we keep smart contracts on the blockchain network, we don't actually keep the codes, keep the Solidity or Viper or any other language, EVM-based language code that we have. We will just keep the binary file of our contracts on the chain because it's pretty less storage consuming and it's easier to deal with, and it's an executable, right? Using this command here, we could extract the binary and ABI files. We'll put them into variables, and because we are gonna deal with them later on. We'll have the same functionality in JavaScript using these syntaxes. We need to import these two packages, and to load the contract, we'll use this syntax here, read file sync. This is the way we create the input for it. Actually specify the language, specify the file, and to compile it, we just first parse, at last parse outcome of solc.compile function, and this here. And yeah, then keep everything in the contract variable here by specifying the Solidity code, the code itself, a smart contract code itself, and name of the constructor. So this was the syntax for compiling. But after compiling the contract, we'll reach the point that we could actually do the deployment. To deploy the incrementer.sol contract, you need to first compile the contract using a script and then create a deployment script file. You can name it deploy.py or .js. And the deployment script file must complete several steps, including importing the API and bytecode, setting up the Web3 provider, defining the account from with the private key, creating a contract instance, building a constructor transaction, because a constructor is like any other function, and you need to call it in a transaction and sign that transaction and then send it using send-raw transaction function that we mentioned before, and wait for the receipt by using the function that returned the receipt to us. It's essential to note that the private key, as I mentioned earlier, I'm going to mention again, it should never be stored in the file. So with these steps completed, you can successfully deploy our smart contract. So now let's take a quick look into the code snippets we have here. So we could simply import API and bytecode, compile, and establish the connection, define variables, public and private keys, and this is an instance of our contract. This is how we kind of make that instance. We need the API and the bytecode that we got from the previous script. So this is the place that we use those variables. This is the way we build the transaction. We kind of define the transaction here. We set the nonce. So in the previous example that we had, this term nonce, we specified a specific value, I think. So here we're using a function called getTransactionCount from that specific address to set the nonce. So if you know the nonce, you can set the value itself, put it here 0, 1. If it's the first time, it's going to be 0. But if you don't have any idea what's the nonce, you can use this function to get the value. And this is the part that you actually sign the transaction. You could basically combine everything here, but we've separated them so it's easier to understand them. And this is the part that we send the transaction, just like the previous example we saw, and then we'll wait for the receipt, and then we'll print out the transaction receipt, that contract address. So this will give us the contract address. So each contract that has been deployed on the chain has a specific address, like any other address, any other account address that we have. And yeah, so whenever we call a function in a contract, we're basically running a transaction on the chain that has to deal with two addresses. One of them is the sender's address, sender the transaction, and the second one would be the contract address. So this address is a unique ID that kind of specifies our contract. We're basically doing the same stuff with JavaScript with different syntax. Once again, that I'm gonna just show the syntax to you, but you can take a more careful look later if you're dealing with JS. I need to mention here that Web3.js is a little bit more popular. So if you're sitting on the fence, not sure about using which one, I recommend you to use the JS syntax and libraries, but both of them could properly get used and there's no issue with any of them.